Hello and welcome to another math tutorial. In the diagram, O is the center of the circle. So the center of this circle is labeled with letter O. And AT is the tangent to the circle at T. Line AT is the tangent to the circle at T. The radius of the circle is 6 centimeters. So the line drawn from the center of the circle to touch any point on the circumference is what we call radius. So in this case, the line which is drawn from the center of the circle to the circumference at T, okay, will be 6 centimeters. And OA equals to 12 centimeters. So which means that from the center of the circle, okay, to the point A, which is external to the circle, is the length of the line is 12 centimeters. So let's not forget that this is also 6 centimeters. That is from the center to the what? To the circumference. But from the center to the point A, which is external to the circle, all right, the length of line OA is 12 centimeters. So our task is to find the area of the shaded region. So to find the area of this shaded region, what we can see here is a triangle, okay, and a sector. So when we can calculate the area of the triangle and that of the sector, and then we subtract the area of the sector from the area of the triangle, that will give us the what? Area of the shaded region. But we also need to calculate, to be able to do that, we need to calculate the what? The height of this triangle. Now, why did I call this the height of this triangle? It is the height because one of the theorems in circle theorem is that when a radius is drawn through the tangent to a circle, okay, then the radius will make an angle of what? 90 degrees to the what? To the, that is the angle between the tangent and the radius will be what? 90 degrees. So that means the radius is perpendicular to the tangent to the circle. Okay, so which makes this triangle a what? A right triangle. So now, on this side, okay, this side AO will be the what? Hypotenuse side, because it is the side opposite angle 90 degrees. Okay, now the other two legs, because we need to calculate the central angle, okay, the central angle, because we need the central angle in order for us to calculate the area of the sector. So to be able to calculate the central angle, so this side will be the what? Adjacent, and this side will be the what? Opposite. So the length of this leg of the right triangle, which is 80, we need to find the length, okay, using what we call Pythagoras theorem. So to find 80, now we say applying Pythagoras theorem. So applying Pythagoras theorem. So we know that to be able to find 80, we have A, that is, we have AO squared equals to OT squared plus, okay, that's 80. We want to find AT. So that means we have OA squared, okay, OA squared. Then we also have, that will be OT squared plus TA squared. All right, it's okay. So this is, so this will be, so we have this to be 12, and that will be 12 squared equals to 6 squared, okay, plus AT squared or TA squared. So we have TA squared. This will be 144 minus 36 equals to TA squared. Okay, 144 minus 36. All right, that will be 108. Yeah, equals to TA squared. So that TA will be equals to the square root of 108. So the length of the opposite side is square root of 108. Okay, this can also be root 36 times 3. So which means TA will be equals to 6 root 3 centimeters. So this is the length of the opposite side of the right triangle. Then also we need to calculate the central angle. So to be able to calculate the central angle, that is theta. Okay, theta is the what? Is the central angle or the angle subtended at the center. All right, so to be able to calculate the central angle, so we can use SOHCAHTOA, okay? Now, let's use what we are given. We are given OT, which is the radius, and also the hypotenuse, which is 12 centimeters. So we have adjacent and what? Hypotenuse. Let's not forget that opposite is the side which is directly opposite the given angle in a right triangle. Adjacent is the side which is beside the given angle in a right triangle, but hypotenuse is the only side which is opposite right angle, that is angle 90 degrees, and it is the longest side in a right angle triangle. All right, so in this case, so we are using SOHCAHTOA, okay, applying SOHCAHTOA. Okay, so we know that cos TOA, that will be adjacent over hypotenuse. Okay, that will be adjacent over hypotenuse. All right, and we know that the adjacent is what? The adjacent, so cos TOA is theta, okay? The adjacent is 6, then the hypotenuse is 12, okay? Adjacent is 6 centimeter, hypotenuse is 12 centimeters, okay? So which means that theta will be equals to the inverse cos of 1 over 2, okay? And the inverse cos of 1 over 2 in radian, that will be pi over 3, okay? You know, 1 pi equals to 180. So 180 divided by 3, that will be 60 degrees. So this will be pi over 3 rad. So this is the central angle in radians. Okay. So like I said, this will be 60 degrees, okay? And then theta will be pi over 3 in rad. This is the angle in degrees. Now, so we now know what the height of the triangle is and also the central angle. So now we can then find the area of the shaded region. So area of shaded region is equals to area of triangle minus area of sector. Area of triangle minus area of sector. Now, like I said, the height of the triangle is the opposite. That's the opposite side, which is side AT, okay? The base of the triangle will be what? 6 centimeters. And that is the what? That is the radius, okay? So area of triangle, which is half times base times height, okay? In this case, the area of the triangle will be half times the base. Let's not forget that the base, okay? The base equals to radius, and that will be 6 centimeters. So that will be 6 multiplied by, then the height. The height is what we calculated here to be side AT or TA, which is what? 6 root 3 centimeters. So this will be 6 root 3. So 6 divided by 2, that will be 3. 3 times 6 root 3. So the area of the triangle will be 18 root 3 centimeter squared. So this is the area of the triangle. Let's not forget that area of triangle minus area of sector, okay, will give us area of the shaded region. So we just calculated the area of the triangle. Now, area of sector. So this is sector, this shape. Now, area of sector will be 1/2 of r squared multiplied by the central angle. And we got our central angle, the size of the central angle, to be 60 degrees, which is pi over 3 in radians. So, and then we know that radius is what? 6 centimeters. Theta is what? Pi over 3 rad. Okay, so this will be area of sector will be equals to 1/2 of the radius, which is 6, and that will be raised to the power of 2 times pi over 3. Now 6 squared, that will be 36. So 36 divided by 2, this will be 18. So 18 divided by 3, that will be 6. So which means the area of the sector will be what? Will be, so the area of the sector, that will be 6 pi over 3, which will be equals to, let's not forget that this is 36 divided by 2, that's 18. Okay, then 18 divided by 3, okay, that will be 6. 18 divided by 3, that will be 6. So this will be 6 pi centimeter squared. Now, area of shaded region. Area of shaded region, which is area of triangle minus area of sector, will now be 18 root 3 minus 6 pi centimeter squared. Okay, now if we change, if you write the value of pi as 3.142 and we use it to multiply 6 and then subtract it from 18 root 3, we'll get 12.33 centimeter square. So the area of shaded region is equals to 12.33 squared centimeters. When we take the value of pi to be 3.142, and we know that root 3 is 1.732. So when we multiply 18 by root 3 and then subtract it from the product of 6 times 3.142, the area of the shaded region will be equals to 12.33 squared centimeter, which is 12.33 squared centimeters. The noblest pleasure is the joy of understanding. Bye-bye.